Hi everyone, welcome back to Java 1 for All. In this video, we are finally going to code some collections, and the first one we are going to talk about is lists, or our lists. So let's go back to collection, right-click, Java class, list test01, and for the 100th time, public static void main. Well, let's go a little bit back in time and understand how things were before Java started getting pretty cool. This is how we used to create lists. Well, technically I started working with Java from version 6 and this was already there. But the package that we have is java.util.list, and this is how we used to work with lists. Basically, you declare on the left side the most generic type, usually the interface, and then on the right side you declare the object, the one that is providing the implementation for that for this interface. We have several types. So if we go to the list, Control B as a beta, we have here a huge documentation explaining that this is an ordered collection. Usually lists, they are backed by arrays, and the difference is that the lists, for example, especially the one that we are going to work with, that is the array list, is just an array that we can resize indefinitely as long as we have memory without having to recompile the program. So as we can see here, list is just an interface, and we have several different implementations for that interface, and array list is just one of them. So this is how it used to look like, Java 1.4. And to add values to this list, you just have to call the add method. And pay attention to the reference that we have here in this parameter is object. So I can technically put everything. So for example, I can add here William. I can add here DevDojo. And I can add other things, but let's see first how we can actually get these values back. So I have here a reference list. Object is an array list, an array that we can resize as long as we have space in memory. And to iterate over, we can either use for each or the index for. Now, for each, we have to first tell the type that we are going to get back from this list. Since we don't know, and even Java doesn't know what we are putting there, the reference here should be object. And we can iterate over names. Now, if you just add here, south name, we will get our values back. So this is how it was before, but the problem is we can do something like this. Technically, it's possible, and it doesn't mean that you should do it because things can get very complicated. For example, imagine that we have an array of names and we, for example, would like to validate, or imagine that this was an array of emails and would like to use matches to make sure that we have the right pattern. So we would need to, following this pattern, use the instance of. So for example, we would need to have name instance of string and so on to make sure that we have the correct value. So this was pretty difficult, and most of the good developers, they never did something like this, mix the types in one array. So from Java 1.5, they introduced what we call generics. We are going to talk about generics in future videos, but basically, if you go back to the list and you know a little bit about generics already, we have this E that usually represents the type of the elements. It's like you can think as the type. Whatever you have E is going to be replaced by whatever you pass from your object creation. So in this case here, we have several methods. For example, we have add, and it's E. And if we replace that with string, we are going to get string E. So the diamond syntax is used to represent the generic types. So I can say, okay, this list is a list of strings. And as you can see, we have compilation error immediately with 1, 2, 3, because of course they are not strings. And the syntax, I think prior to Java 1.7, you used to have to write kind of the same in both sides, but from Java 1.7, you don't have to write the type anymore. Why? Because they need to be exactly the same. So if you have a string here, should be string here. You cannot have like string and the object as integer. And if you have string on the right side, you also need to have string on the left side. As you can see, the mandatory is on the left side of the reference variable. So this is what you're probably going to see nowadays. So we have here our list of names, and if you try to add and you press Ctrl P, you will notice that we have string. So basically, generics was a way that Java found to kind of force compilation errors. But remember, Java is a language that always tries to have backwards compatibility. So once you compile this code, you will, and you take a look at the compiled code, you will see that basically this is what it becomes. So to maintain backwards compatibility, you cannot force the list to be string. Why? Because technically it could break everybody's code. So this is something that after you get the code compiled will be removed, and the JVM will just see something like this. Okay, so now since we know for sure that we have strings here, we can change this to also string. And this gives us flexibility to work directly with a string type. So if I want to use matches, it's available. If I want to use replace, it's also available. So everything that's available in the string is available for us here. So this is how we iterate over passing through for each. How do we iterate over if we are using indexed for? Let's give some separator here. So you know that when we are working with index 4, we will need a reference variable that will represent the index. And then we have to iterate over until the size. Now, how do I get the size of lists? So list has a method, very intuitive, called size. So remember that arrays, it was length and it was an attribute. So we didn't have the parentheses. But size is method. In the list, that's why we have to use it like this. And then the same. Oops. Pretty straightforward. And now to actually get the data, if we were working with arrays, it would be something like this. But this is invalid syntax for collections. And to get something from a list, you still need the index, but you get from get. And we have the return type that will be a string. So get index position I. Control Shift F10. And as you can see, we have exactly the same result. And to prove that we can resize, we can add here, for example, names.add. And I'll add my last name. And you will notice that at the end now, we have another value in that array. Talking about the size, by default, if I'm not mistaken, the size of the array list is 16. So when you add until 16, the same capacity will be used. But for example, if you add another number or another name or something that will change the capacity to 17, Java will just double the size. So the next size will be 32. And if you add 33, Java will double again, and from 32 it will be 64, 128, 256, and so on. So basically, the capacity will always double once you reach the limit. If you know how many objects you are going to have inside that list, you can, for example, start directly with that capacity. And you have to be careful because this capacity is going to double again. Now, the capacity, I think the performance doesn't change that much, so I don't think you have to worry that much about it. Resizing, of course, there is a little bit of overhead because you have to resize it. Of course, you have to move the data along to the new array. But well, the best practice is to give the capacity if you know the capacity prior to instantiating the array list. Okay, so basically this is it for now. We know, and this is very common, the way we create here is probably what we're going to see everywhere. You always work oriented to interfaces. It's possible to just get the most specific type and have here as a reference variable. This is not wrong. It's syntactically and technically correct, but it doesn't mean that it is the best practice. And we are going to see in future videos why it's a good idea to work with the most generic type on the left side as a reference variable. So this is everything that I want to tell you for now. Let's continue with more information in the next video. Bye.